Dear all, I welcome you for the lecture session Airport Drainage. This is Dr. N. Ramesh, Department of Civil Engineering, K.S.Rangasamy College of Technology. Introduction. A well-designed airport drainage system is a prime requisite for operational safety and efficiency as well as pavement durability. Because whenever the rain comes around 9 months, heavy rainfall in our India, southwest monsoon as well as the northeast monsoon, that a lot of flood are coming. The airport drainage is very much important to drain the water and to safeguard the pavement. Inadequate drainage facilities may result in costly damage due to flooding, constitute a source of serious hazard to air traffic, erosion of slopes, saturated and weakened pavement of foundations. Airport drainage introduction. Airport drainage system is similar to street and highway drainage design. So, like our roads, we are providing the drainage for the in the roadsides. So, whenever the rain comes, the rainwater easily drained. The like that airports are needed the proper drainage system. Airports are characterized by large areas of relatively flat gradient. Airports require prompt removal of surface and subsurface water. Hence, they need in an integrated drainage system. Removal of water should be done from runways, taxiways, aprons, parking lots, etc. Next one is the airport drainage runoff is removed from airports by means of surface ditches, inlets, and an underground storm drainage system. Airport drainage can be described into the following sections. The first one, estimation of runoff. Second one, design of basic system for collection and disposal of runoff. Third one, provision for adequate subsurface drainage. The first one is the estimation of runoff. So, number of formulas and analytical procedures exist for finding runoff. All methods are not precise and accurate. Of the available methods, rational method is widely used one. Coefficient of runoff, rainfall intensity, duration and frequency are the factors on which this method depends on. The first one, only a portion of the rainfall flows as runoff. Some water evaporates, some intercepted by vegetation, some infiltrates into ground. Airport drainage channels and structures must be designed for the precipitation losses. Losses depends upon the slope, soil condition, vegetation and land use. Some of these factors change with time. Important to assess the effects of planned development works on the runoff as they may disturb the existing pattern of runoff. Runoff coefficient indicates the hydrologic nature of the drainage area. It is defined as the ratio of quantity of runoff to the total precipitation that falls on the drainage area. The below table gives the recommended values of runoff coefficient. So values of runoff coefficient type of surface for all watertight roof surface areas factor C 0.75 to 0.95. For a asphalt runway pavements 0.80 to 0.95. For concrete runway pavements 0.70 to 0.90. For gravel or macadam pavements 0.35 to 0.7. For impervious soils heavy, it's 0.4 to 0.65. Impervious soils with turf 0.30 to 0.55. For slightly pervious soil, 0.15 to zero point 0.4. For slightly pervious soil with turf, zero point 0.1 to zero point 0.3. For moderately pervious soil, 0.05 to 0.2. For moderately pervious soil with turf, 0 to zero point 0.1. For slopes, generally followed 1 to 2 percentage. Rainfall intensity is the rate at which rainfall is typically expressed in inches per hour. Because of the parabolic nature of weather, it is discussed in terms of its frequency and duration. Procedures for the construction of rainfall intensity duration curves have been published by the FAA. Making the use of such charts, we can determine the intensity of 5-year rainfall of desired duration. So here it is shown for example of calculation of rainfall intensities from charts can be done as follows. For the duration 30 minutes, chart value 1.37 inches, 60 by 30, its intensity is 2.74 inches per hour. And 60 means it is 1.73 inches into 60 by 60, it is 1.73. If it is 120 duration minutes, 2.10 inches, 60 by 120 equal to 1.05. To obtain values for the short duration rainfalls, the following relationship between a 30-meter rainfall and 5, 10, 15 minutes amounts may be used as 5 minutes ratio 0.37, 10 minutes 0.57, 15 minutes duration 0.72. The next slide. In the previous example, we took the 30 mm rainfall intensity, that is 1.37 inch, will be multiplied by the ratios given to yield the rainfalls of smaller duration as follows: 0.51 in 5 minutes, 0.78 inches in 10 minutes, 0.99 inches in 15 minutes. After that, values will be converted into inches per hour to get the intensity. Now the above obtained values can be used for drawing a 5-year storm intensity duration curve. Similarly, for other periods like 2, 10, 20, we can develop the curves. Here, a intensity duration curves for storms vicinity of the example. Here duration of rainfall, it is given in the x-axis as the 0, 5, 10, 15, 20 to 130. It is the rainfall in minutes is given, and the y-axis intensity of rainfall inches per hour is given. So the charts are obtained for the 2 years, 5 years and 10 years intensity is shown in the graphical representation. A designer must choose the correct curve for the design. While designing the correct curve, various curves are given and the correct curve should be used for the design. This involves the weighing and judging various factors related to physical and social damages that might result from the flood of a given frequency. Normally, a return period of 5 years is used for the design of drainage system at airports. Choosing a higher return period will return a costly design which is not economical. So the design should be economical. It should be the taking in the consideration. The time of concentration is the next area. In the design of airport drainage facilities, a rainfall duration equal to the time of concentration is chosen. It is the time taken by the water droplet from the uh, remotest area of the catchment to reach the inlet of drainage. It consists of two components: time of surface flow or inlet time, time of flow within the structural drainage system. Inlet time can be obtained using the formula, that is capital D equal to capital K into T square. Capital D is the distance in meters, T it is inlet time in minutes, Capital K is a dimensional empirical factor depends on the terrain and extent of vegetation, distance to drain inlet. Following is the formula recommended by the FAA for the finding the time t. The t is 1.8, 1.1 minus c into d power of whole divided by s power 1 by 3, where t equal to surface flow time in minutes, c equal to runoff coefficient, s equal to slope in percentage, d equal to distance to the most remote point feet, or else following the figure can be used for finding the approximate inlet time. The time of flow within the structural system can be determined by dividing the structure length in feet by the velocity of flow in feet per minute, which is following to determine the appropriate values. Here, the same type of graphical representation which is shown, that is surface flow time curves, which is shown in x-axis. The distance d feet is given in the y-axis. Okay, the formula t equal to 1.8, 1.1 minus c into root of d divided by root of s. Use the formula distance in excess of 800 feet. So it is given for the various constant values, that c equal to 0, c equal to 10, c equal to 20, and c equal to 30, 40, 50, 60, 70, 80, 90, and 95. It is a time also taken into consideration minutes. And the surface flow curves which are created here, which is taken for the design of the drainage system. The rational method is recommended for the calculation of runoff from airport surface, especially for drainage areas less than 200 acres. The method is expressed by the equation Q equal to C by A. Q equal to runoff CFS, and then capital C runoff coefficient typical values are given in the table. I equal to intensity of rainfall inch per hour for estimated time of concentration. A equal to drainage area acres. Area may be determined from surveys and topographical maps or aerial photographs.